and Assalamualaikum. We are from CS1435C and our group consists of 4 members. First, me, Nur Anira binti Syamsul Johari. Second, Nur Akilah binti Yahya. Third, Karunisa binti Saiful Mizan. And lastly, we have Nabilatul Husna binti Zulkifli. In this video, we will talk about problem that related to application of separable equation. To be specified, we will discuss about Newton's law of cooling or warming.
First, we go through the introduction. Newton's law of cooling or warming states that the rates of change of the temperature of a body is proportional to the difference between the body temperature and the surrounding temperature. Then, the model is expressed as dt over dt equal to k times t minus tm subject to t0 equal to t0 and t1 equal to t1. After that, the equation 1.1 is solved using separating the variables and integrating both sides of the equation, and we will get tt equal ce to the power of kt plus tm.
Today, I will present about problem statement. So, restaurant Vecna is selling daging harimau menangis that use tenderloin meat as their main cut of beef. Following the quality standard operating procedures require a lot of preparations. So, in order to keep this meat fresh and in compliance with the recipe's requirements, it must be frozen overnight. The ability of the freezer to completely freeze the meat was found to be at a temperature of negative 15 degrees Celsius, which is necessary for the storing of meat. Afterwards, the kitchen staff took the frozen tenderloin meats from the freezer to begin the defrosting process. Meats were put into a chiller that maintained a constant temperature of 4 degrees Celsius to keep it fresh while the meat was still defrosted. After 30 minutes, the temperature of the meat increased from negative 15 degrees Celsius to 0 degrees Celsius. The meat will be chilled until it reaches a maximum temperature of 2 degrees Celsius. Therefore, meats in the chiller were partially ready to be cooked, whereas the cooks should be take out the meat as soon as the order was received. The meat from the chiller was removed as the last step and left to defrost for 2 minutes approximately with a surrounding constant temperature of 20 degrees Celsius. The meat's temperature increased to 5 degrees Celsius after being exposed to the surroundings for 1 minute. At a certain temperature, the meat was ready to be cooked after 2 minutes left outside. Therefore, defrosting helps rustle up the meat and cook it more thoroughly. Here we have two questions. First, how long does the frozen meat in the chiller change from 0 degrees Celsius to 2 degrees Celsius? Second, what is the temperature of the meat after 2 minutes were left outside before being cooked?
The first question is, how long does the frozen meat in the chiller change from 0 degrees Celsius to 2 degrees Celsius? From the problem statement, we can gather some information, which is the temperature of surrounding, which is 4 degrees Celsius, and the initial temperature of the frozen meat is negative 15 degrees Celsius, and after 30 minutes, the frozen meat being moved into the chiller, the temperature of the meat becomes 0 degrees Celsius. By using this information, we can find the solution for this question. By using the model that being mentioned in the introduction earlier, we can start our solution with d capital T over dt equal to k capital T minus 4, which is 4 is the temperature of surrounding object. Therefore, we move t minus 4 into the left side and we move dt into right side, and we need to integrate both sides, and it will be ln t minus 4 equal to kt plus constant c. And to eliminate ln, we need to multiply both sides with exponent, and it will be exponent ln t minus 4 equal to exponent kt plus c. After we eliminate the ln in the left side, and it will be t minus 4 equal to c exponent kt. And we move the constant to the right hand side, and it will be t equal to constant c exponent kt plus 4. Therefore, we have obtained the general solution, which is capital T in bracket t equal to c exponent kt plus 4. By using the information that we have from the statement, which is t of 0 equal to negative 15, and then we equal it with our t of t, and it will be negative 15 equal to c exponent kt, t is equal to 0 plus 4, and then we solve. It will be c equal to negative 19. Therefore, we have the value of c, and our t of t will be negative 19 exponent kt plus 4.
Then we can find the exact value of k using the same ways by substitute the t into the variable t. Then we get k equal to negative 0.05194. Next, we will get the equation that describing the temperature of frozen meats at time t. After that, we can answer the question, how long does the frozen meats in the chiller change from temperature 0 to 2? We can use the equation that we get and equal to 2. And we get t equal to 43.34 minutes. That means the frozen meats in the chiller change from temperature 0 to 2 at 43.34 minutes.
In this question, we need to know the temperature of the meats after 2 minutes were left outside before being cooked. We need to collect all the data that we get from the problem statement, and it's given that the temperature of surrounding or ambient is 20 degrees Celsius, and it's also given that the temperature of the object at 0 minute is 2 degrees Celsius, the temperature of the object at 1 minute is 5 degrees Celsius, and of course, we need to find the temperature of the object at 2 minutes. The rate of change of the temperature is dT over dt is equal to kT minus Tm. But in this case, our Tm is 20, so it will be kT minus 20. We will write as dt over t minus 20 equal to k dt. And then we need to integrate both sides, and it will be ln t minus 20 equal to kt plus c. We need to use exponent on both sides to remove the ln, and then we get t minus 20 equal to ce to the power of kt. And then we bring negative 20 to the right hand side, we get t equal to ce power of kt plus 20. The temperature of the object at time t is equal to ce to the power of kt plus 20. Now we need to find the value of c. We know that t0 is equal to 2, right? So we need to replace t with 0, and then it will be ce to the power of k multiplied with 0 plus 20 equal to 2. And then 0 multiplied with k, we get 0, and then exponent to the power of 0, we get 1, and then it will be c. Positive 20, we bring it to the right hand side, and then we get c equal to negative 18. We replace the c into the equation, and then we get the temperature of the object. Time t is equal to negative 18 to the power of kt plus 20.
The first step is to substitute t with 2 as in 2 minutes by inserting 2 sk to find the temperature of the meat after 2 minutes. The third step is to substitute the equation with 1, and that makes the equation as shown, which is 5 equal to negative 18 exponent to the power of 1k, and then solve it to find k. And we got k equal to negative 0.18232. So this discussion we obtained from our case study is that we learned that the first order differential equation are used in real life to solve many problems, including cooling and warming problems. We can conclude from the equation or problem statement in this case study that by using the application of first order differential equation in the cooling and warming problem, we can compute the expression for time needed for the frozen meat in the chiller change from 0 Celsius to 2 Celsius. Throughout the calculation, we also calculate the temperature of the meat supporting the constant temperature of the chiller at 20 Celsius after 2 minutes. As a result of our calculation, we have determined the expression and the temperature of the meat after 2 minutes.